Welcome to Fact Sphere, the realm where knowledge meets mystery and the unseen threads of mathematics, science, and history are revealed. Here, numbers whisper their secrets, formulas unlock ancient truths, and the legends of the greatest mathematical minds come alive. Step inside the sphere, where every fact is a portal and every formula is a key. This is Fact Sphere. Dare to know? More than 2,500 years ago, Pythagoras and Euclid revealed one of mathematics' greatest secrets, the Pythagorean theorem. But what if we told you there's more to this iconic formula than meets the eye? Join us as we delve into the fascinating history of the theorem and uncover the hidden gems that have remained shrouded in mystery for centuries. Our story begins in ancient Greece, where Pythagoras, the legendary mathematician, captivated by the mysteries of the universe, dedicated his life to unraveling the secrets of numbers. With his fellow scholars, they formed a secret society known as the Pythagoreans, where the most brilliant minds gathered to explore the unknown. Their motto, "Number rules all." It was within this exclusive circle that Pythagoras and his comrades pondered over the perplexing properties of triangles. One fateful day, while studying the harmonious proportions of musical chords, Pythagoras stumbled upon a groundbreaking discovery. He found that the square of the hypotenuse in a right-angled triangle is equal to the sum of the squares of the other two sides. This revelation, now known as the Pythagorean theorem, sent shockwaves through the scientific community and laid the foundation for many future discoveries in mathematics and science. But did you know that this iconic theorem has a darker side? Allegedly, Pythagoras and his followers were so consumed by their own brilliance that they kept their discoveries a secret from the rest of the world. Some historians even claim that Pythagoras went as far as to put anyone who revealed their secrets to death. The lengths they went to protect their intellectual property are truly astonishing. As the legend goes, one of Pythagoras's followers, a man named Hippasus, dared to share the secrets of the brotherhood with the outside world. Outraged by this betrayal, Pythagoras and his disciples confronted him, but when Hippasus refused to recant his actions, they banished him from the group. In a fit of rage, Pythagoras vowed that Hippasus would never find peace, and as punishment, he cursed him to an eternity of restless wandering. This chilling tale serves as a reminder that the pursuit of knowledge comes at a cost, and that the thirst for power can corrupt even the brightest minds. Amidst this shroud of mystery and intrigue, the Pythagorean theorem stands tall as one of the most influential discoveries in the history of mathematics. Its applications are vast, spanning from architecture to astronomy and beyond. This fundamental formula has shaped our understanding of the world and continues to be a cornerstone of modern science. Now let's dive deeper into the historical context surrounding the Pythagorean theorem. The ancient Greeks were fascinated by the concept of harmony and balance, and they believed that these principles were reflected in the natural world. When Pythagoras and his fellow mathematicians discovered the relationship between the sides of a right-angled triangle, they were not just solving a mathematical problem. They were uncovering a deeper truth about the universe itself. Pythagoras and his students spent countless hours observing the patterns and relationships in musical chords, and they realized that there was a mathematical basis for the harmony they heard in music. They noticed that the ratios between the lengths of vibrating strings were directly related to the intervals between musical notes. This led them to explore the properties of numbers and their relationships, which eventually culminated in the discovery of the Pythagorean theorem. But the ancient Greeks were not the first to ponder over the mysteries of triangles. The Babylonians and other civilizations had already made significant progress in geometry. For example, the Babylonians had developed a table of squares, which is essentially a list of perfect squares for numbers up to 60. This table enabled them to calculate the area of squares and rectangles, and it also provided them with some knowledge about the properties of triangles. Pythagoras and his followers built upon the work of previous civilizations, and they made some incredible discoveries about the properties of triangles. One of their most famous discoveries was the relationship between the angles and sides of a triangle. They knew that the sum of the angles in any triangle was always 180 degrees, and they also knew that the longest side of a right-angled triangle is opposite the right angle. They used these principles to develop the Pythagorean theorem, which states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. But the ancient Greeks didn't stop there. They also explored the properties of acute and obtuse triangles, as well as the relationship between the sides and angles of different types of triangles. Their work laid the foundation for many important concepts in geometry, and it helped pave the way for future discoveries in mathematics. In fact, Pythagoras and his followers were so obsessed with the beauty and harmony of mathematics that they believed that numbers themselves could reveal the secrets of the universe. They studied the properties of numbers and their relationships, and they made some amazing discoveries along the way. For example, they discovered the infinite nature of prime numbers, and they also developed some early forms of trigonometry. The Pythagorean approach to mathematics was not just about solving problems or finding solutions. It was about understanding the underlying principles and patterns that govern the natural world. They believed that mathematics was not just a tool, but a reflection of the divine order of the universe. To fully grasp the significance of the Pythagorean theorem, we must understand the state of mathematical knowledge at the time. Before Pythagoras, the understanding of right triangles was limited. There was no known method to determine the length of the hypotenuse, given the lengths of the other two sides. This lack of knowledge posed significant challenges in various practical applications, such as surveying land or calculating the height of objects. Then came Pythagoras and his revolutionary theorem. His discovery provided a direct and elegant solution to this long-standing problem. With a simple formula, one could now calculate the hypotenuse of a right triangle by squaring the lengths of the other two sides and taking the square root of the sum. This breakthrough not only solved a practical problem, but also opened up new possibilities in geometry and mathematics as a whole. It gave rise to a new understanding of the relationships between the sides and angles of triangles, laying the foundation for further advancements in the field. Moreover, the Pythagorean theorem had far-reaching implications for various disciplines. In engineering and architecture, it became a fundamental tool for ensuring stability and strength in structures. By understanding the relationship between the sides of a right triangle, engineers could design buildings, bridges, and other structures that could withstand external forces and maintain their integrity. Furthermore, the theorem had profound implications for astronomy. As astronomers began to map the heavens and study the positions of stars and planets, they needed a way to calculate distances in space. The Pythagorean theorem provided a means to determine the distance between celestial bodies based on their angular positions, allowing astronomers to make more accurate observations and calculations. The impact of Pythagoras' discovery extended beyond the practical applications. It also sparked a deeper appreciation for the beauty and elegance of mathematics. The simplicity and universality of the theorem continue to captivate mathematicians and science enthusiasts alike. It stands as a testament to the power of human intellect and the relentless pursuit of knowledge. Today, the Pythagorean theorem remains a cornerstone of mathematics, serving as a fundamental principle in various areas of study. From calculus to linear algebra, its applications are widespread. It is a gateway to more advanced mathematical concepts and a testament to the enduring legacy of Pythagoras and his followers. So the next time you gaze upon a right triangle, remember the brilliant minds that sought to understand its secrets. The Pythagorean theorem is more than just a formula. It is a symbol of human curiosity, ingenuity, and the relentless pursuit of knowledge. And so our journey through the hidden gems of the Pythagorean theorem comes to an end. We've uncovered the fascinating history, the intriguing stories, and the profound impact of this remarkable discovery. But before we part ways, let's take a moment to appreciate the lasting legacy of Pythagoras and his fellow mathematicians. Their dedication to unraveling the mysteries of the universe, their pursuit of harmony and balance, and their belief in the power of mathematics continue to inspire us today. So as you explore the world around you, keep an eye out for the hidden gems that await your discovery. Embrace curiosity, seek harmony, and let your thirst for knowledge guide you. Who knows what wonders you might uncover? Thank you for joining us on this episode of Fact Sphere. If you enjoyed this journey through the Pythagorean theorem, don't forget to subscribe for more mind-bending adventures. And if you have a burning desire for knowledge, leave a comment below with your thoughts, questions, or suggestions. Together, we can unlock the secrets of the universe. Until next time, keep questioning, keep exploring, and keep seeking the answers that lie within the sphere of knowledge.